Now, in addition to the way the pixels are represented, the invention of the internet forced us to start thinking about the size of images. And not just the size and the number of pixels, but the size of images in terms of the file size. Now, you might, if you've played around with images at all, what you'll know is that the tiny little images that you might download from the web, like an animated GIF file, are way smaller in size, like a 20 kilobytes, way smaller in size than maybe a picture you take on your iPhone, which might be like 20 megabytes in size. But the invention of the internet forced us to start thinking about how can we make pictures or images small enough that they're easy to download on our very slow dial-up modem connections that we had at the time. Do we worry about size anymore? A little bit, but not nearly as much. Right now, we're more in an age of, well, we have fast connections to the internet, so let's make the quality look really good, which usually means a larger file. But we're still using compressed files. And that's what GIF or GIF, I'm not going to get into an argument with anybody here, but GIF or GIF, JPEG, and PNG, those are what are referred to as compressed file formats, meaning that the data, the RGB and A, in some cases, for each pixel is encoded using a formula that reduces the size of the file while doing as little damage to how it looks as possible. And your mileage may vary with these because they are compressed. So you have to give a little bit on quality, but the trade-off, if you do it right and you use the right kind of format for the right image and you know what you're doing, you can still get a high quality image with a much smaller file size. So I'm going to just sort of give you an idea of how these work. So graphics interchange format, the way it works is by reducing the number of colors in an image. Okay, so a GIF file has only room for 256 colors, which is what indexed means. So first of all, it takes the image, it looks at it and says, what are the 256 most common colors in this image? And it makes all of the colors in that whole image one of those 256 colors. And instead of saying all of the data for each color, it now just says this is color number 1, this is color number 2. So already you're taking the data that's represented in that image and you're reducing it quite a bit. So if you think about how you could represent that image using as few data points as possible, it's indexed. The other thing that graphics interchange format does is called horizontal striping. So it encodes the width of the image and then it uses horizontal stripes. And so if you have 10 pixels that are the same color in a horizontal stripe, it will represent those 10 pixels by saying, I'm going to have 10 of color number 1. And so instead of representing that in each individual color, you get 10 of color number 1, it reduces that image even further. Other things that graphics interchange format or GIF can do is animation, which is what they're famous for. GIF and animation have become synonymous these days. And the other thing that you can do with a GIF file is transparency, but not alpha transparency. The way GIF handles transparency is it allows you to assign one of the colors in that image to be the transparent color. So it's completely transparent or completely opaque. There's no in between, which makes the edges of a transparent GIF file look kind of rough if you don't have it on the right background. Graphics interchange format is really good for logos, for line art, comic book art, cartoons, anything with large blocks of color, especially horizontal stripes. That's where it excels. You're going to get the best look for the smallest file format from one of those images. JPEG is literally short for Joint Photographic Experts Group. It was designed to reduce the size of photographs. It uses interpolation, and it does not reduce the number of colors, but what it does is it takes out pixels, like every third pixel maybe, and then estimates what that's going to be using a mathematical formula. So the way a JPEG looks when you reduce it a whole bunch is it starts to develop artifacts because it's guessing too much. The more it guesses, the smaller the file size, but also the worse the quality. So JPEG actually has a quality setting when you save that file size so that it feeds into the formula, the function. It takes an argument called quality, and it says, I'm going to use that to determine what percentage of the pixels I'm guessing. So, and of course, all of this that I'm saying to you is like the short version. I don't want to teach a whole class on just file format compression because it's not that exciting. Portable network graphics is a newer format, and it is really good. It tends to be a slightly larger file size, but the quality for both logos and photographs tends to be much, much higher. PNG is the default format for most things. Okay. Now your iPhone still takes JPEG pictures. It just renames them to something else and adds a little bit of data that's iPhone specific because Apple's kind of got to, flip everybody off out there. So, but portable network graphics do what's called lossless compression, which means there's virtually no reduction in the quality while still reducing the file size relatively significantly. And it does alpha transparency, which means you can have partially transparent pixels, which makes the transparency look very smooth and very natural. It gives you the ability to have a whole image that's halfway transparent, which means you can see what's behind it if you use it on a web page or if you layer it on top of another image. So it's really good, it's really advanced, and it's high quality. So those are the three formats that you're going to play around with the most. There are other formats, but we're concerned with these mostly because those are the digital formats that are the most popular today.